Good day, beautiful people. I trust you are doing good today. All right, I bring to us set. Set is a beautiful concept in mathematics as well as further mathematics. And of course, it finds expression in courses and topics like logic, the principles of induction and deduction, as well as the abstract algebra. Right, so without taking much of our time, we will be delving straight into the concept, starting with the definition. All right, so we'll start with set is a collection of well-defined objects. Collection of well-defined objects. I won't be saying much about that, but then from the example, I think we'll be able to get some things. So the examples are a set of mathematical instruments. When we talk about mathematical instruments, what comes to mind is first of all your pencil, as simple as that, your eraser, your sharpener, then moving on, you have your rulers, you have your set squares, you have your compass, you have your protractor, and what have you. Anything that aids you in any construction or drawing in mathematics, we call them set of mathematical instruments. And you can see that those concepts are actually well defined, having a common name to themselves, mathematical instruments. All right, the second one is a collection of tools in a carpentry workshop. And you know what tools the carpenters use. They make use of the hammer, they make use of the nail, they make use of pincers, uh, as many other tools. We have drilling machines in the carpenter's shop, and then we have a collection of books in the library. So when you enter a library, you see that there are different sections of the library. We have section for journals, we have section for everyday delivery like the newspapers, then we have section for different books having different subjects. We have the mathematics subject books, we have the what is it called, English subject books, the literature and other literary studies. We have those books all defined in different aspects of the library. Then we have different kinds of games, of course. So we have football games, we have volleyball games, we have the lawn tennis, we have badminton, and when we talk about the track event, we have the race athletes. So these are different collection of things, and when you have collection of things like this that can be grouped together as a well-defined object, so we call such grouping, we call them sets. Okay. All right, so we'll move straight to different concepts and operations on set. And first of it all is the universal set. So what is the universal set? We'll be looking at the subset, we'll be looking at the superset, we'll be looking at complement of a set, we'll be looking at cardinality of a set, we'll be talking about the union of set as well as the intersection of set. So we move on to the other side of the board. All right, here we go. So we're starting with the universal set. The universal set is the set of all elements under consideration. It is also called the umbrella set. I want you to imagine it in this scenario. The universal set is seen like a mother hen that gives covering under her feathers to all her children. So all other sets that will be considered in a given question will definitely be drawn from a universal set that has already been given in that question. And how do you identify the universal set in a question? These are the symbols for identifying the universal set. So as I say, the symbols for the universal set are curly U and curly E. So when you see any of these two symbols in a question, you tag them the word universal set. Thank you. So the next one is the subset. The subset is a smaller set that is contained in a bigger set. The symbol is this. There's a symbol. So this example will explain it better. For example, if P is set 1, 2, 3, 4, 5, 6, 7, 8, and set Q is set of 2, 3, 5, and 7, then Q is said to be a subset of set P and is written as Q is a subset of P. That tells you that Q is a smaller set than set P. Not just a smaller set than set P. Every element in Q are also contained in P. So you look at it in this format. Q is less than P. I believe this symbol is, you're familiar with this symbol. All right. In similar manner, I'm building on this idea. We have the superset. The superset is a bigger set that contains a smaller set in it. The symbol is this. This is a symbol for the universal set, superset rather. For example, set P is called the superset of set Q in the example above. We say set Q is less than P. So Q is a subset of P. But this time around, P is greater than Q. And in that manner, we say P is a superset of Q. So that's why it is written. Set P is called the superset of set Q, as given above. And is written as P is a superset of Q. And of course, again, see it as the symbol greater than. That is, P is greater than Q. And of course, every element in Q also is in what? P, as P contains all the elements in Q. Alright, so you permit me to please skip a step. Here we are supposed to have complement of a set before cardinality, but I choose to go with the cardinality first before the complement. So what is cardinality of a set? Cardinality of a set tells us about the number of elements in a set. Now, this is set P. How many elements do we have, or how many different individuals do we have in set P? Here they are 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the number of elements in set P is 8. And in the case of set Q, how many elements are we having there? 1, 2, 3, 4. So the number of elements in set Q is what? 4. So it is also called cardinality of P is 8. Cardinality of Q is what? 4. Talking about the number of elements in a set. So we are going for the last three now, which are complement of a set, union of set, and then intersection of set. We have a complement of a set. Given that U, which is the universal set, and that set A is a set drawn from U, the universal set, then the complement of set A, which is written as A complement or A prime, is the set of all elements in U but not in A. Alright, so that's English. Let's go to the mathematics aspect. For example, this is set U that has been given according to the statement 1, 2, 4, 6, and 11. And this is set A, and of course set A 2, 4, 6 is drawn from set U 2, 4, 6. These are the elements of set A. They are drawn from the element of set U. That tells you that A is a subset of the universal set. Then A complement or A prime is the set 1, 11. What does that mean? These 1, 11 are the elements that are found in U, which is the universal set, but they are not found in A. There is 1 in U, there is no 1 in A, so it makes this list. There is 2 in U, there is 2 in A, it doesn't make the list. There is 4 in U, there is 4 in A, it doesn't make this list. There is 6 in U, there is 6 in A, it doesn't make this list. There is 11 in in U, but 11 is not found in A, so it makes the list. So A complement or A prime are the set of elements in set U, universal set, but are not found in what? Set A. So that helps you to explain the long English that you have there. Thank you. Alright, so we move on to the next one, union of sets. This is the set, this is the merging of two or more sets. When you merge two or more sets together, the element of two or more sets, the set that I produce for you is the union of those sets. So the symbol, this is the symbol for union of sets. An example is given below. This is set A, and set A is described by the elements 2, 3, 5, and 7. Then we have set B described by the elements 1, 2, 3, 4. So we talk about A union B, that is the merging of the elements in A and B together. A union B, according to the name, union of sets. So we have, first of all, to write down the element of set A, which are 2, 3, 5, and 7. So we have 2, 3, 5, and 7 here. Then moving on to element of set B, element in set B to be listed. We have 1 here, we have 1 here. Because 2 is already listed in among the elements in set A, to avoid unnecessary repetition. So 2, 3, they are already listed. So we don't need to rewrite them as they have already made the list. Then the next one that is not in the list is just what? 4. So these are the sets contained in the union of set A and set B. So that's what union of sets talks about. That's what it means. Merging of the elements in set A together with the elements in set B. Alright, so we move on to the intersection of set. So what is the intersection of set? When two or more sets have common elements, we say they intersect. So when you have two sets, two different sets, or 3 or 4 different sets, and every member of every set A, B, and C, or with D having elements together that are common. So the listing of those elements are called the what? Intersection of those sets. Don't mind my English, please. So we have A intersection B. Using the same example, set A is 2, 3, 5, and 7, and set B is 1, 2, 3, 4. So what elements do they have in common? Of course, is the element 2 and 3, and that is why the intersection of set A and B is 2 and 3. So that's what we mean by intersection of set. And the symbol for intersection is the symbol. So those are the concepts and ideologies that we can have under the topic set. There are more actually. For example, we have the concept of equality of sets, we have the concept of equivalent sets, we have the concept of the power set, we have concept of the finite and infinite sets, and many others. But then basically these are the concepts that are usually being asked about. So basically these are the concepts that we have until I come your way next time. Please enjoy this.